Solve quadratic equations using square roots. Here's an important theorem. If x squared equals m, then x equals plus or minus square root of m, provided that m is greater or equal to 0. Here's our proof here that if x squared equals m, x equals positive or negative square root of m. Beware, this theorem is written as a conditional or if-then statement. The if statement is the premise, and the then statement is the conclusion. Note, if x squared equals 9, then x equals positive or negative 3. There are two solutions. However, the square root of 9 is 3 only. It's only one value. But as you can see, if you put positive or negative 3 into here, you will get 9 as a result. All right, here's an example. So solve for x. We have x squared equals 9. X equals positive or negative the square root of 9. The square root of 9 is 3, so we have positive and negative 3. The two solutions are confirmed by the graph. So this is the graph of x squared, and we can see that two inputs x, two different inputs, negative 3 and positive 3, have the output of y equals 9, and that is confirmed here. Solve for x. We have x squared equals 5, so m is 5. Therefore, x equals positive or negative the square root of 5. So here we have our graph of x squared, and if we put in negative square root of 5 into this function, we will get an output of y equals 5. And if we put in positive square root of 5, we will also get an output of y equals 5. So there are two inputs that produce the output 5. The new theorem can be used with substitution. Here's an example. Solve for x. So all we've done is replaced x with x minus 2, and that would lead us to the next step, which would say that x minus 2 equals positive or negative square root of 5. So our answer ends up being 2 plus or minus the square root of 5. We move this 2 over to the other side. So here's the graph of x minus 2 squared, and we put in 2 minus square root of 5, we will get an output of 5. If we put in the 2 plus square root of 5, we will also get an output of 5. So note, the axis of symmetry of the graph is x equals 2 here, and the solutions are symmetric with x equal 2. True or false? All right, x squared equals 49 implies that x equals positive or negative 7, and that is true. You could put positive or negative 7 in here, and you will get 49. All right, the square root of 64 equals positive or negative 8. Well, this is false. The square root of 64 is positive 8. 64 equals 8. So it is not positive or negative 8 here. All right, the next one, x squared equals 21 implies that x equals the square root of 21. This is false because it's actually x equals plus or minus the square root of 21. The square root of 21 is only going to be a positive number, so you have to put this positive or negative out front so that we get the two different solutions. All right, x plus 5 squared equals 13 implies that x equals negative 5 plus or minus square root of 13. This is true. So if we have our x plus 5 squared equals 13, that means that x plus 5 equals plus or minus square root of 13, and then we just move that 5 over to the other side, negative 5 plus or minus the square root of 13, so this is true. And finally, the square root of 81 equals 9. This is true because the square root has to be only one positive number like this. If we wanted plus or minus the square root of 81, we would get plus or minus 9, but this is how this is true. Solve 2x minus 1 squared equals 20 using the square root method. All right, so first we can say 2x minus 1 equals positive square root of 20, and then we can solve for x. So we can break this up, then bring a 2 out front, and then move this 1 to the other side, and then divide the whole thing by 2. Or we could set it up at the beginning as 2x minus 1 equals negative 20. Then we can go through the same process to solve for x. So we see that our solution is x equals 1 plus or minus 2 square roots of 5 over 2, because this is a plus sign here and this is a minus sign here, so we can combine those into two different solutions.